Here I'm going to talk about mathematical functions. They crop up in all sorts of Leaving Cert maths questions, calculus, algebra, and some of the trickier questions that come up at the end of the paper. So you may have seen this before where you have an input value, and we usually call that input x. And what happens to the x is it changes into another number. That's just called its output. Quite often we refer to the output as its y value. Okay, so this is effectively a function which is a number machine. So in this instance we could have an x value of 1 and a y value of 2. We could have an x value of 2 and a y value of 4, and we could have an x value of 3 and a y value of 6. So if I plotted those points there with the x value and the y value, I could actually just show the relationship between the points by drawing a line. If you want to know the relationship between them, we could look at what the equation of that line actually is. So for example, in this case, I'm just going to write out the points first, and then we're going to write out the equation of the line. So each of the points in red are the points 1, 2, 2, 4 and 3, 6. They are just points on the Cartesian plane. I've drawn them here, and they're known as ordered pairs. So effectively we have a set of ordered pairs there, 1, 2, 2, 4 and 3, 6. They are just points on a plane, xy points. So technically a set of ordered points is called a relation, and a function is just a relation in which each x value has a unique y value. Okay, so for every x value that we have here, there is at most one y value here. So the relationship between those points can be written down in terms of the equation of its function. Now the equation of this particular function is y equals to 2x, because to get any y value we just have to double the x value. So the equation of this function is y equals to 2x. Now we can also write that, and you may have seen this, as f of x is equal to 2x. That just means the function of x. It can also be written as f colon x goes to 2x. So in other words, if you ever see this, it's just another way of writing y, and if you ever see this, this is also just another way of writing y. So here, to get the y value, we just doubled the x value. As I'm going from the x to y, we just had to double it in each case. So that gave us the equation of this particular function. Just some more terminology. The domain is the set of all possible x values in our function, and the range is the set of all y values. To know whether something is definitely a function or not, there's a test called the vertical line test, whereby if you just draw out a sketch of the function, and if you can draw a vertical line through it, if that vertical line hits the curve more than once, then it's not a function. I'll talk about that in a minute. So now we're going to look at some functions that we've become familiar with in Leaving Cert Maths and also in Junior Cert Maths. So the first function we've already actually looked at. It's called a linear function, and it's the one above. A linear function will look like this, where we have y is equal to some number times x plus another number. In the case above, that other number was just 0. Okay, but the important thing to note here is that it is just x, not x to any other power other than 1. Okay, so y is equal to just something times x plus another number. In that case, we just get the equation of a line, like that. And that's called a linear function. The next one we'll look at is a quadratic function. The only difference now in a quadratic function is that y, or f of x I've called it now, is equal to some number a times x to be squared, plus another number b times x plus another number c. That's called a quadratic function. We've looked at these before. Quadratic function can either look like that if a is greater than 0, or it could actually look like that if a was less than 0. So again, a vertical line drawn at anywhere there hits the curves only 1. Okay, so that's known as a quadratic function. And the last one we look at is a cubic function, which you don't do at Junior Cert, but you do at Leaving Cert. And a cubic function will look something like this. Okay, it will usually hit the x-axis 3 times. It has 2 turning points, which we'll look at when we go into calculus in a bit more detail in later videos. But here you'll notice that it starts off low, goes up and then down and back around and just continues up. This is a case when a is greater than 0. If a was less than 0, we have the other curve like this, goes down, up and then down again. Okay, that is where we have a being less than 0. So they are both known as cubic equations, and the important thing to note is that y is just equal to some number times x cubed plus another number times x squared plus another number times x plus d. Okay, so that's a cubic equation, that's a quadratic, and that's a linear equation. There are 3 types of functions that we come across quite regularly at Leaving Cert. Now, if you're ever asked to draw one of these functions, you could either draw out a table where you have a domain range of x values and you plug in the x value into the equation for the function to find what the corresponding y value is. Then you just sketch the points, okay, and you draw a curve to suit that sketch. What I'm going to be looking at next is calculus, and that really helps us when we're sketching curves and drawing curves of quadratic and cubic functions. Okay, there are methods using your calculator which are perfectly fine to be able to plot points and therefore sketch a curve as well, but I'm not going to look at that in this video. The next type of function I want to look at, and the last type I want to look at here really, is exponential functions. So where we have f of x goes to some number a times some number b to the power of x. So in these cases, usually what happens is the function either starts off quite low with minimal change, and then that change increases dramatically, or else vice versa. You have a large increase to start with and then minimal change. And we're going to look at 4 different types here. So the first exponential function I'm going to look at is when we have a being greater than 0, so that's a positive number, and b being greater than 1. So the one I've plotted is a is 1 and b is 2, for example. So we've got f of x is equal to 1 times 2 to the power of x. So f of x is just equal to 2 to the power of x. So I'm plotting it in the range of starting with x equal to minus 2 and going up to x is equal to 3. And I'm literally just plugging in to see what happens. Well, if x is minus 2, then the y value becomes 2 to the power of minus 2, which is 1 over 2 squared, which is 1 over 4. So it started very low. Then when x is minus 1, here the y value becomes 2 to the power of minus 1, which is just 1 over 2. So that's a half there. So small changes in y at that point. And then suddenly, as x starts to get more positive in this direction, okay, y increases quite a bit. So you can see when x is 0, y is 1. When x is 1, y is 2. Then when x is 3, y is 8. So it goes up quite dramatically. Okay, so that's an exponential function where we have x being a power. All that happens when we change a or b to be either positive or negative values, the shape of that curve changes, but it's a similar enough type of situation where we start to see dramatic increases or decreases with a changing value of x or y. So the next case I'm going to look at is where a is still greater than 0, so a is positive, but b this time is between 0 and 1, so b is a fraction between 0 and 1. So here we can see a different type of exponential function where a is equal to 1, b is equal to a half, so this time b is a fraction between 0 and 1 and a is greater than 0. So the function is f of x equal to half to the power of x. Okay, and we can look at what happens if x is minus 2, that's going to be a half to the power of minus 2, which is 4 here. When x is minus 1, we go down to being 2. Okay, when x is 0, we go down to 1. And when x is 2, we go down to a quarter. Okay, so very small gradual changes in y as x gets bigger. So the next one I'm going to look at where a is negative. Okay, and we can see that the shape changes with routine increases in x. Not much happens to y at the start, but then y decreases dramatically. So if we let a is equal to minus 1, for example, and b equal to 2, we have a function f of x is equal to minus 2 to the power of x. When x is minus 4, there y is going to be minus 1 over 16. Okay, so very close to the value 0 there. When x is minus 1, y is becoming minus a half, so a gradual decrease in the y value. And when x is 4, y was minus 16. Okay, so we can see dramatic changes there. And the last case we're going to look at for our exponential functions is where a is negative, so it's less than 0, and b is now a fraction between 0 and 1. So if we look at the function minus a half to the power of x, if x this time is minus 4, our y value is very, very negative, minus 16. When x is minus 1, so we just increase it by 1, our x value now becomes minus 2. When x is 4, so quite positive, y is minus 1/16. So starts off with large increases in y, and those increases in y decrease dramatically, okay, as y gets more and more positive for that case. So I've looked at some functions. The aim for these videos isn't to go through all the terminology regarding functions, to go through all the limits regarding functions. It's just a brief recap of some of the functions we're going to come across at Leaving Cert Maths. In the following videos, I'm going to look at limits of functions, and I'm going to look at calculus.